Alright, so I'm going to talk about some objectives from Chapter 7. This is the third objective and the ninth objective. This one talks about limiting and excess reactants, and the ninth objective talks about percent yield and percent error. So to start with, limiting and excess reactants. So I made this equation up here. Of course, these are our two reactants and these are our products. And this is the precipitate that we produced, and we're given the grams of our precipitate and both reactants. So we're given three things, and then with those three things we do stoic twice. Not once, we do stoic twice. So I can write this out for you guys. We're going to start with 6.8 grams of iron chloride. And what we're going to try to do is we're going to convert this grams into sodium chloride. Oh, not an 8. And this is our stoic step. Because we have 3 moles over here and 1 mole of this, it will be 3/1. Going to NaCl. Just to clarify. And we're going to end by converting it to grams. And this will equal 29.0 grams of 3 sodium chloride. So that's one stoic step. Then we have to do it again with sodium hydroxide. So, we start with oh wait, that's our stoic step. And they both have 3 moles, so it's just 3/3. Still 58.44, but this time we get 31.4 grams of 3NaCl. And these grams is what we get out of the periodic table. And as you can see, these numbers are fairly close, but they're a little different. And your limiting reactant is going to produce the less amount of your precipitate. So, because iron chloride only made 29 grams and sodium hydroxide made 31.4 grams, our iron chloride is our limiting reactant, and this is our excess reactant. So whatever makes less is your limiting reactant. Sometimes you're only given one mass. Sometimes you're not given another mass of your reactant, and then you assume that's your limiting reactant. And this also can work with gas stoichiometry, but you're just going to have to transfer a few more things using the ideal gas laws. But that's the basics. So, with Objective 9, it's talking about percent yield and percent error, which it kind of nicely connects into what I just wrote above. So, I wrote out the formulas. Percent yield is actual over theoretical times 100, and percent error is your experimental value minus your predicted value over your predicted value, and absolute value signs times 100. And these are to make it a percent because they're both percentages and they make it back into a normal number. So, and I wrote above a translation. Actual means what you got in your experiment. theoretical means what you did mathematically with your stoichiometry. And so experimental could also be actual, and predicted could also be theoretical. It's what you predicted in your math. But, I mean, you could use either one. So, I'm going to pretend that we did an experiment with this equation. And let's say in the experiment we got 24.3 grams of NaCl. So, we're going to say that's our actual value. And our theoretical value is what we got in our math, which was 29. Let's make that grams. Multiply it by 100 to make it a percent. And this is 83.8. So that would be our percent yield. And that's also going to be a bigger number. That's the way I differentiate the two. This is going to be a bigger number, and the percent error is hopefully going to be a smaller number if you did the experiment right. So we can do this again. 24.3 minus 29, because that's what we predicted in our math. Make sure we have absolute value signs, because this will be a negative and we want it to stay positive. Well, multiply by 100. So I'll write it down below here. And this ends up being 16.2%. So you see the difference? This was a very small number and this is a very large number. But they both use the same terms. So there you go. Those are my two objectives.